All right. All right. Thank you, everyone, for coming to our last solo meeting for this quarter. Today, we have a Pandas workshop, which is a library within Python, which helps you do data analytics. So we hope you guys are excited for that.
As always, don't forget to sign in, scan the QR code here to get your points, and we will be announcing the winner of the raffle by the end of this meeting.
So here is our schedule for the last 2 weeks of the quarter. Today, like I said, we have our Pandas workshop, and then next week on Thursday around the same meeting time, I think we have a joint meeting with FinTech where we'll be talking about personal investing and how you can manage your personal investments and what smart decisions you can make regarding that. So with registration for fall quarter approaching, we thought that we'd give you some class recommendations for quant classes, but even if you're not a quant concentration, you can take these classes in order to get like a more analytic side to your education. So for me, my class suggestion, one of them was Stat 324, which is applied regression analysis with Olga. She's super chill, and the class uses, or my class at least, uses Jump in order to do some of that analysis. So I think that's really useful. And then also, my second suggestion was Biz 392, which is business application development with Professor King. And this class is essentially just going through the basics of Python and teaching you what you need to know in order to get a better understanding of that programming language.
So my class recommendation is Stat 331, which is statistical computing with R with Professor Bodwin. And I really like this class because I thought it was really fun working with R. And one really cool thing about this class is that at the end of the class, you got to work on like a final project, which is like basically just you doing analysis in R using everything you've learned that quarter. And you get to do it about any topic you want to, which is super cool.
And then I have a couple on here. My first class recommendation is Stat 434, Statistical Learning with Kelly Bodwin. I can't say it's the easiest class I've ever taken, but I've learned a lot and it's really interesting, especially if you're going into like data science or data analytics. And the second one is Stat 324. This is the same class that you already mentioned, Applied Regression Analysis. I took it with Jimmy Doi. He's super helpful, really nice. I learned a lot during that class, so highly recommend it as well.
And then Adrian isn't here, but I'll share his recommendation. So he recommends Biz 306 with Rhonda Beeman, as well as Biz 387, which is organizational behavior with Calvin Stevens, and then also Biz 342, which is corporate finance with Sharon Dobson.
And my two class recommendations are Econ 395, which is programming for economics with Katya Vasilaki. You get introduced to Python here and you go pretty deep into it. And you also learn some Pandas and Jupyter, which is what we'll be covering today. And also Biz 319, which is accounting IS with James Caney. He's a super nice professor, and it's a super great way to kind of get more information or educate yourself a bit more about accounting IS.
So the internship search for this summer has kind of come to an end already. But if you want to get a step ahead for next summer, you can drop into the Career Readiness Center. They help you with your resume. They give you tips for networking. They also help you with looking for internships and full-time positions too. And they also conduct mock interviews and other things to help you prepare for that internship or full-time search. So you can drop in Monday through Thursday, 10 to 12 p.m., or you can also schedule an appointment. And that's also Monday through Thursday, 12 to 3 p.m., or Friday, 10 a.m. to 12 p.m. So you can scan that QR code on the screen to get more information on that.
And then hopefully you guys already know this by now, but the deadline to declare your concentration is coming up. So if you're a sophomore or transfer student, make sure you do this before that deadline, or you will get a hold on your account. If you're a change of major student, you don't actually have to meet that deadline, but make sure you get that done as soon as you can.
All right, so the certification that we're highlighting this week is the Google Analytics certification. So for those of you who don't know, Google Analytics is a web analytics service, And what's cool about this certification is that it's free, and the class that prepares you for the certification is approximately like 6 hours. So it's pretty like short. And this is like a good skill to have. It'll teach you some like basics about analytics, and it'll provide you a foundation for learning other analytical software such as SQL, R, and Tableau. So if you don't have anything to do over summer, I definitely recommend checking it out. The link for it is in the chat. And if you want to contact us, you can get in touch with us through our Instagram, which is @CalPolyQuack, our Gmail, which is cpquack@gmail.com. And if you want to join the mailing list, you can do so by scanning the QR code or the link that's in the chat.
And then if you want to get more connected with us, you can join our Slack, which will also be posted in the chat. And also, if you want to see past recordings of meetings and our workshops and get caught up, you can also check out our YouTube channel.
And here at Quack, we're open to suggestions. So if there's anything you'd like to see in Quack or next quarter, or anything you'd like to see changed, you can let us know through our suggestion box. And you can access the suggestion box by either scanning the QR code or the link in the chat.
So today's meeting, like I said, we have our Pandas workshop. It's going to be me, Conan, and Michaela going over the topics that we have listed on screen. So I'll let Michaela start off with the intro to Jupyter Notebook.
Okay, so I'm going to share my screen and just show you guys how to get this all open. And then I'm also going to drop a link in the chat to the data and also the Jupyter Notebook file. So let me send that right now. If you follow that link, let me just share my screen and I'll show you what it pulls up. So that's going to pull up just this Google Drive folder, and it has this Jupyter Notebook file in there called Quack Pandas Workshop. And it also has this salaries CSV data file. So you'll need both of those. So make sure you download them to your computer and then move them to a directory that you know where they are. So like for me, I put them in this Pandas Workshop folder that's on my desktop. I know exactly where they are and they're in the same spot. So make sure that those two things, you know where they are and that they're together. The next thing, if you're on a Mac, just pull up your terminal. Same thing with Windows, just go to the command line. And then you're going to want to change your directory so that you are where those two files are. So if you do CD, that's change directory. I'm going to go desktop. So now I'm at my desktop and you can see it shows up there. And then I'm going to do change directory, and then I'm going to go into that folder. Since there's a space in there, I have to put quotes around the folder name. And then, so now we're located in that folder. So now once we're there, once you've like navigated to where the directory where your stuff is, then you can just type in Jupyter Notebook into your command line or terminal, hit enter. And then it might be a little slow, but it'll pull up the Jupyter Notebook on your web browser. So now you can see both of those are showing up there. So I'm going to go ahead and open this Pandas Workshop notebook. We already have the code in there for you guys. So you'll be able to just kind of follow along with what we have. But this is what a Jupyter Notebook looks like. Just a little intro to what that is. Basically, each one of these little rectangles is where you can insert your code. And then when you run it, the output shows up right underneath. So there's output here because this has already been run, but there isn't always stuff there. And then up here, we just have kind of text boxes. They're called Markdown, or if you want to do like heading up here, it's the same thing. You can basically just adjust like how big or small you want it to be with the amount of hash marks. So just know that that's there. And then if you hit Command Enter or hit that Run button, it'll run it. And that's how you get this text to just look like that. So I will keep going. First of all, we are using Pandas today. If you don't already have that library installed, you'll need to install it from your command line. Hopefully everyone already has that. If not, you just do pip3 install Pandas. But I already have it installed, so I'm just going to keep going. But basically, this is just a library that allows you to kind of make data frames and manipulate your data within Python. So make sure you run that, or else nothing below it is going to run. So the first thing we're going to focus on is just reading in the data set. So we already have these in the same folder, so we should be good to go. We're going to be using this Pandas data frame to read it in with the function read CSV. And then in parentheses, you want the name of the file. So if you somehow change the name of the file, make sure you edit that here as well. And then we're going to set it to a variable data frame so that when we want to access it later to do stuff, it's just a simple name that we have to type in. And then this next thing is basically, it's called head. It's just going to bring up the first, I guess we specified 10, but you can change that number to however many you want or leave it at the original amount. But it's just going to bring up the first 10 observations in this data set. So if I hit Command Enter and run that, this is just a little preview of what our data set looks like. So basically, we just have some information on professors, their service, their salary, stuff like that. So that's what we're going to be working with. Down here, this actually isn't really necessary. We decided not to use this data set, so you can kind of ignore that. But these are just a few things that you're going to want to do every time you read something in. You're going to want to know how many rows and columns you have. Get an idea of how much data do you really have. So if you use data frame, remember that's the name of our data, .shape, and run that, it's going to bring up that you have 78 rows, so 78 observations and 6 columns, so 6 variables. And then if you want to know what the columns or variables are named, you can just do df columns, and it'll bring up all of the names of our variables. We have rank, discipline, PhD, service, sex, and salary. And then just notice that it is an object. If you're more familiar with Python, that might make a little bit more sense, but you can kind of ignore that. And then also, this is kind of a weird looking type thing. So if we want to change that list of variable names into something a little bit more digestible, we can change this. This is what we just did, the df column, and we can make it into a list and name it variable list. Are you guys having trouble hearing me because of the wind at all?
No, it's good.
Okay. And then practice with loops. If you were in our last Python session, we talked a little bit about for loops. So if you want to loop through this variable list we just created and print out each of the column names, we can just practice that. So for I in variable list, which is what we just created, we're going to print that specific variable name. So it's already, the output's there, but basically just loop through and print all the variable names. And then also you want to be making sure that you're aware of what data types you have. So if you're doing modeling or anything, you're going to want to know if you have character data or if you have floats or integers, just make sure you know. So to do that, you're going to want to do, this is your data frame. And then if you do these square brackets and put in one of the column names or the variable names within that, you can pull out the data type of that specific column. So if we do that, it looks like the data type for the salary variable is int 64. And similarly, we can pull out the data type for all of the columns at the same time if we just don't specify what variable we're looking at. So same thing, it just pulls out all of them. And then another thing you're going to want to make sure to do is just kind of get some basic numeric statistics. So like right here, if you do our data frame dot mean, this is the function, it's going to pull out the mean amount for all of our variables that are numbers, I guess. So it's not going to do anything for like character variables. If you run that, you see our mean PhD is 19.7, service 1505, and salary is about 10,800, or sorry, 108,000. You can do similar things with things like standard deviation. I'm not going to go over all of the options, but just know that there are functions like this if you want to look into them a little bit more, that you can run on your different numeric variables. And then you can also, if you want to just calculate, say, the mean for the first 50, you can also do that by just typing in like head 50 and then running your mean function. So for the first 50 observations, this is your average. And then I will let Zoo take it away with some more data slicing and grouping.
Cool. Thank you. Can you guys all see my screen? All right, cool. So now we'll move on to data slicing and grouping. So the first thing we're going to do is we're going to extract a column from our data set. So there's two ways you can do that. The first way is to put in brackets after df the name of your column in quotations. And then that way, as you can see, the output shows that we do have just the sex column displayed here. And again, we used head just to see the first 5 observations in the data set. And then the second way to extract the column is to just use the column name after a period after your data set name. So df is our data set dot, and then our column name, which is sex dot head, and then that gives you the same output as well. So after that, we'll move into looking at summary statistics for a column. So in order to do that, you have to use the method describe and the summary statistics. So then if you want the summary statistics for a specific column, you can do what I mentioned previously is either use the bracket method or just by using the dot column name method. So here we're looking at the summary statistics for our salary column, and we can see it gives count, mean, standard deviation, minimum, the quartiles, and then the maximum. So you can like create a box plot with this, or you can just kind of look at how the distribution of the data as well. And then if you want like a specific, value from this summary statistics, you can just do pull the column out again, and then just do dot mean with the parentheses at the end, and then you'll just get this value right here. So this is a good way if you want to like compare the mean to something else or make it a conditional in an argument or something. This is a good way just to pull out the mean from a specific column. So now we'll go into grouping the data. So over here, we want to just create a whole new data frame with our grouping. So that way we can keep that original data frame the way it is. So in order to group within Pandas, what you do is you specify the data frame, so that's df, and then you do dot, and then your method is going to be group by with no spaces or underscores. And then in parentheses, you will put the column name that you want to group by. So for this specific problem right here, we're going to be grouping by the rank. And we can see that it seems like there's only 3 different ranks. So it'd be professor, associate professor, and assistant professor. So we'll be having 3 groupings there. And then the brackets over here, or these double brackets, allow you to signify which columns you want to keep. So because we are creating a new data frame, we're going to be grouping by the rank column. But then with that data frame, the new data frame that we create, we only want to keep rank, of course, because we're grouping it. And then we also want to keep salary. So we can see scrolling back up to our whole data frame, we are just going to keep rank and salary here. So that means discipline, PhD, service, and sex are all dropped in our new data frame. So after we do that, we can look at our new data frame here. So we do df underscore rank dot head. You can actually include an argument into the head method to determine how many rows you want to see. So then we see that it did indeed just keep rank and salary. So then now with a new data frame, we want to look at the means. And since it's grouped by rank, the mean salary for every rank will be output here. And then since we only have one quantitative variable, we don't have to specify that we want the mean salary. It'll just automatically do it for us. So we can see that the professor rank has typically more higher salary than associate or assistant professor, which we kind of understand since those first 2 positions are a little bit lower than the professor rank. So if you don't want to go through the hassle of creating a new data frame, you can just do it here and just have it output with your original data frame. So that way the original data frame isn't changed, but you still get that same output. And you can see when we do dot mean without specifying any arguments, it just gives you the mean for all the quantitative variables in that data frame. So if we only want the means for salary, we can specify, like we said, in the brackets what we want. So this is single brackets, and then that kind of specifies what we want what we want the mean to calculate. And then afterwards, so the double brackets, so the double brackets do the same thing too. It just looks a lot cleaner because over here, it doesn't look as nice because it gives us the name and also the data type as well. But if we want it formatted a lot nicer, we can just use double brackets. And then now we'll move on to filtering. So with filtering, we tend to use just conditional arguments in order to filter out data. So for this one, we'll be creating a new data frame. And then in order to do so, we do df, which is our original data frame. And then in brackets, we set the conditional argument on what we want to keep. So for this one, we want to filter out the column salary by anything that's greater than 100. And then after we do that, we have that df100 data frame. And then building on top of that, we want to group that data frame by rank. So then we do that again with the dot group by with our new data frame here. And then in quotations, we just put rank in order to signify that that's the column that we want to group by. And then from there, we can group, and then we can find the mean for that, since we do only keep salary from this first step right here. So this dot mean will just look at the salaries that are greater than 100, and then look at the mean for those salaries. So we can see here that the salaries tend to be higher, and it gives us essentially the same results here, with the professor being higher than both the assistant professor and associate professor position. So then we can also put this all into one line so that you don't have to do it step by step. It looks a little bit more complicated. So as you continue programming with Python, you'll tend to do this a lot more because it saves a lot of time. And as well, you don't have to keep creating new data frames based on these different commands or functions that you're using. So then now if we want to group using two variables, since we do have two categorical variables in our data set, what we can do is, again, use the dot group by. And then in the parentheses, we have to use the brackets. And then the first column that you put in those brackets is the first column that you're going to group by. And then the one after is the second one. So it's hierarchical in that sense, in where it groups by the rank and then it groups by the sex after. So with the output here, we can see that on the leftmost, it has associate professor, assistant professor, and professor. And then within each rank, it has a breakdown based on sex. And then again, we use the double brackets to signify which quantitative variable we want to calculate the mean for. And then it does show the salary for each sex for each rank. So that's the way we can group by two variables. So then there is also two-way filtering. So with this, we're going to subset the data again. We're going to create a new data frame. And then, like mentioned before, df, then in brackets, you specify your column, which is df bracket salary, and then specify a condition, which is greater than 120,000. And then once we do that, we can see that the output has the observations that have this only salary over $120,000. And then if we want to have data for only female professors, we can see that we subset the data again. And then in order to use a string as a conditional argument, what you have to do is you have to do equals equals. If you do one equal sign, that's signifying that you want to do an assignment. So if you want the sex column to have only females, you have to do equals equals and then in quotations female. And you can see that we keep only the female professors and associate professors and assistant professors in our data frame. So then we'll move on to sorting now. So then what we do here is we use the dot sort values method. So you'll have to do df dot sort values in order to sort your data. And then the argument that you use in your sort values method is by. So for this, we're going to do by equals, and then in quotation service. And then we can see that it, in the new data frame we created, it has the service, it sorts by service. So it starts ascending, I believe. So all these services right here is 0. So then in order, if we want to do descending, what we do is we have to put a second argument in our dot sort values, in our dot sort values method, and then we have to make sure that is false. So this argument right here is default set to true, so that's why we didn't put anything in our as a second argument over here. But if we want to have it descending, we have to put a second argument saying ascending equals false. And then also when we do this, we have to make sure that there is brackets around our column name in order to make sure that Python recognizes that column properly. So then now we can sort actually by 2 values. So just kind of like with the grouping, we have to put this in brackets as well. And then it's also hierarchical in the sense that the first column that you put in the by equals argument is what it sorts by first. And then after that, it sorts by salary. So for this, we put service first and then salary second. So we can see that service is prioritized here. So all the service equals 0 values are listed here. And then from here, we have the salary, which is descending. So in order to do one ascending and one descending, we set that second argument ascending equals, and then we put in brackets what we want the ascending, if we want it to be ascending or descending, based on the order that we specified in the by argument. So because we put service first, we put ascending for true for that, and then salary second. So the ascending value, so it's going to be descending rather than ascending. So that's why we have service starting at the lowest value, and the salary is starting at the highest value for each service value. And then now Conran will talk a little bit about mutating columns.
All right, so one of the cool things that you can do in Pandas is that you can actually add your own columns to an existing data frame. So right here, I just wanted to create a column called 5 and then just fill it with a bunch of 5s. So the way you do this is you write the name of the data frame that you want to add a new column to, and then kind of like a similar way to like accessing a column, you kind of just type the name of the new column in brackets. So like I have brackets and then in quotes is 5. And then you need to assign it a value that you want the column to equal. So, and like this is kind of like a simple case. So I just did 5. And if I print out like the data frame, you can see that df sorted now has a new column called 5, and every single value in 5 is 5. And one thing that's also cool is that you can edit columns. So if we look back at our 5 column, let's say I want to increment it by 1. I can do that by doing df sorted. So I'm accessing the 5 column, and I just add 1 to it. And then I need to assign that back to the original column 5. So when I do that, now you can tell that everything in the 5 column has a number 6. So it's kind of odd that our 5 column has a bunch of 6s. So maybe we can rename it. And the way you rename it is by using this rename function. So the way you use the rename function is you type in the name of the data frame where you want to call the function on. You do dot rename, and then it has an argument called columns. So you do columns equals, and then you put these little curly braces, and then first you put the old name of the column in quotes. Then you separate it with a colon, and then you put the new name of the column. And one interesting thing about this function or this method is that it returns a whole new data frame. So we actually need to assign it back to our old data frame variable. And if we print out that new return data frame, you can see that there's a column called the 5 is renamed to 6. So why would we want to really use mutations? So one example of why we can use them is if we want to standardize a column. So if you guys remember from your stats class, standardizing is just pretty much finding like the z-score. And we can do that by taking the original value, subtracting the mean, and then dividing that by the standard deviation. So using some of the functions that we talked about earlier, we can find the mean and the standard deviation. So the mean, you just access a salary mean, and you call mean on it. And for standard deviation, we access salary and we call standard deviation on it. So we create a new column called standardized salary, and we take the value in each row, subtracted by the mean, and then divided by the standard deviation. So that will give us this column right here called standardized salary. Are there any questions about mutating variables? No? All right. So I'm going to move on to joins. So what are joins? Joins are pretty much just a way to combine two data sets if you have some common values. So here are two data sets that I created just about some of the Quack board members. So this one has me, Zoo, and Michaela, and it has our major and our concentration. And this other one has me, Zoo, and Adrian, and it has our position and year. So as you can see, there's a lot of like common variables of me and Zoo between both of them. And let's say I wanted to combine them and get one data set that has major, concentration, position, and year. So the way I do that is with the join. And so you may have noticed that Michaela is here in this data frame, but she's not in this one. And Adrian is here in this data frame, and he's not in this one. So the way we deal with data that's missing, like not common, is like what each different type of join is. So the first join I'm going to talk about is called the left join. So I called this data frame the left one, and then so this one right here, and then this one is the right one. And basically the left one is pretty much the one where you call the merge method on, and the one that you pass inside the merge method is your right data frame. So the merge method keeps everything in common between both the right and left data set, and it also keeps the extra stuff from the left data set. So as you can see here, me and Zoo, which is a common stuff, has been kept, and then Michaela, which was the extra thing from the left data set, has been added. But as you can see here, we have values in both data sets for me and Zoo, but there's no values for Michaela's position or year, and that's why it was left as NaN, which stands for not a number, or just like none or null. And the right data set, right join works kind of like the same way as a left join. It's just the opposite. So it keeps everything extra from the right data set. So as you can see here, Adrian is here, and me and Zoo, which are the common things, are here. And there's no values for Adrian's major or concentration. So when you're working with like data analysis and stuff, it can be kind of problematic when you have these not numbers. So if you just want to keep only the common things, you can do that by doing an inner join. And an inner join, like I said, it just keeps all the common things. So there's me and Zoo, and then we have the values for all 4 columns. And then an outer join is pretty much just the opposite of an inner join. You just keep everything. So the extra things from the left column and the extra things from the right column are just all combined. So you have me and Zoo, and you have values for everything. And then you have Michaela here, but no values from the second data set. You have Adrian here with no values from the first data set. And yeah, do you guys have any questions about joins or anything? All right, yeah, I think that covers it.
Cool. All right. And we have one last thing to cover. There are no other questions. Michaela?
So obviously, thank you to everyone who came to any of our meetings this quarter, but we did have a special person who came to the most and got the most points, and that's Angela. So thank you, Angela, for coming to all of our meetings. and she will be winning a gift card. So we will contact you about that, but congrats.
Thank you.